Okay, ladies and gentlemen, thank you so much for being with us today. We gathered for another webinar session with the title of Sustainability in Oil and Gas and Petrochemical Industry. Before we begin, let us understand what the PES Day is all about. For your information, Power Engineering, Power and Energy Society, the goal is to engage all the PES volunteers and practitioners with PES history and on 5 PES pillars for the more power to the future vision. So the first vision is advancing global participation. Second, educating the future workforce. Third, industry activity trends. Ensure standards leadership and participate in regulatory initiatives. As we know now, globally, many countries are still predominantly dependent on coal and oil for electricity, transport, and goods. Therefore, it's up to us that we need to take an action now to change this, as we all need to create awareness among engineering community and public towards changing to a more clean and renewable source of energy. For your information, this year is the third IEEE PES Day celebration, where we celebrate the unity, strength, and achievement of IEEE PES Society and all engineers around the world. Let us all together work to bring more power to the future with affordable and clean energy. Today we have another distinguished speaker coming from industry, Mr. Eric. I will go through with his introductions later. But before we proceed, let us introduce you a bit more about IEEE PES PES Society. For that, I would like to invite Dr. Haroon Rashid, IEEE PES Malaysia Executive Committee, to present the details about IEEE PES. Over to you, Doctor.
Thank you very much, Ayar Noor. Let me share my screen. Am I audible to you?
Yes, sir.
Okay, let me share my screen. All right, can you see my screen?
Yes, we can see.
Okay, actually, the voice is bouncing back. I think someone's mic is not muted. I think you need to mute someone's mic, otherwise I won't be able to speak.
Okay.
All right. Thank you very much once again, Ayar Noor Mohammad Fazli, for organizing this webinar. My name is Haroon Rashid, and I'm from IEEE Power and Energy Society. I'm the Malaysia section lead, as well as I'm the Students and Young Professionals Chair for IEEE Power and Energy Society Malaysia Chapter. Before I begin, I guess, Ayar Noor, can you hear me? I think you need to turn off your microphone as well. The voice is bouncing from your side, I believe. Okay, now it seems clear. Yes. Okay, let's begin. All right, so once again, welcome to IEEE Power and Energy Society webinar. Today, this is 16th webinar in the same series, and thanks to Ayar Noor Mohammad Fazli for inviting the speaker as well as me to present a little bit about IEEE Power and Energy Society. So I will just not take long time, maximum 5 to 10 minutes, just to give you an overview of what IEEE is and what we do in IEEE. So moving forward, IEEE is world's largest professional association, and the tagline of IEEE is advancing technology for humanities. We have around 422,000 plus members all around the world, and they are covering more than 160 countries. We have about 123,000 student members, and what we do in IEEE is we organize the conferences Every year we organize webinars, seminars like this. Due to COVID-19, now we turn to webinars. Usually we organize seminars, technical events. Then we organize the conferences. So conference is one of the main thing that IEEE is very well known to many people. So we have like about 2,000 annual conferences around the globe. If we talk about technical bit, we also IEEE have something called IEEE Explore. Those of you who have been publishing papers with IEEE or similar other publishers, you might know about IEEE Explore. So IEEE Explore basically publishes all your papers, and it's a Scopus Index citation publisher. We have like 200 plus top cited periodicals, and then there are about 49 technical societies, technical communities, and councils altogether under IEEE. And socially, there are IEEE has some groups which are focusing on humanitarian efforts, where they are looking forward to specific projects which cater any type of help that they can do to the humanity by going into the humanitarian projects. Then there are some certification programs for those who are engineers. They need to gain their IR status or professional engineer status. So for that, they need to take some CPDs or continuous professional development hours. So for that, IEEE helps out as well by arranging those courses which are needed for them to complete their annual CPDs. Okay, as I mentioned that IEEE has many societies, so there are altogether about 39 technical societies under IEEE, and IEEE Power and Energy Society is one out of them. You may have heard of IEEE standards as well. Under IEEE standards, the very famous is the one we use for Wi-Fi. The Wi-Fi standard is basically from IEEE standards. And if we talk about Power Energy Society, is the second largest technical society under IEEE. So our basically main goals under Power Energy Society, or in short PES or PES, we basically focus on growing and maintaining your technical expertise, getting connected you to other professionals by organizing some webinars, events where you do your networking, and contribute to the future of power and energy. And if you are a member of IEEE as well as member of IEEE Power and Energy Society, you save money on joining the programs or conferences. Okay, technically, as I earlier mentioned, under Power and Energy Society, technically you can find some resources which are like online webinars and tutorials, which are available at Power and Energy Society website. Then on-site training and workshop, I already mentioned. Then we have a technical journals of Power and Energy, and we organize the courses for industry. So basically, our purpose is to focus on practicing engineers member to elevate them and to keep them update with the technical community, technical society, so that they remain active with their CPDs or PGHs. Okay, IEEE also has a PES Resource Center. You can just Google it, or I will later on share the web link as well. IEEE PES Resource Center has a lot of tutorial videos. You can find technical reports of the previous conferences, journal articles published under Power Energy Society. And then there are conference slides of previous conferences held all around the globe. So these are all resources which are available free to all IEEE Power and Energy Society members. In terms of global engagement, IEEE is covered all around the world, and it's divided into regions. From region 1 to 7 is in United States, and then region 9, sorry, 1 to 7 is in United States and Canada. Region 9 is Latin America. Region 8 covers Africa and whole Russia and Europe. We are in region 10, and region 10 is one of the largest region in terms of overall IEEE members. And in terms of Power Energy Society members, of course, they are if we collect region 1 to 7, they are more, but individually region wise, Region 10 is the most strongest in the region, in the whole world under IEEE. Here are some of the pictures of IEEE PES leadership. These are the PES chairs starting from 1994, since our existence in Malaysia, till 2020. And our current chair 2020 is from University of Malaya, Professor Hazli bin Mukhlis. So these are their photographs of all our past chairs and current chair. Okay, what we do in detail under PES is we do the invited lectures like today's lecture. Then we organize conferences within Malaysia as well and overseas. And every year we have an Outstanding Engineer Award. So if you are a PES member and you qualify for that, you can definitely apply for it, or your friends can nominate you. Then we make the bridge from academia to industry. So it's like a linking between industry and academia, which we are trying to help reaching the industry with the academia, or academia with the industry, vice versa. Then we organize technical activities, final year project competitions every year in almost several universities. We sponsor the final year projects. And also we organize another thing called senior member drives. So basically under IEEE, there are a few levels. If you are a student, you can join as a student member, or if you are a postgraduate student, you can join as a graduate student member. After these members, after these two categories, if you are already graduated, you are no longer a student, you can join IEEE as a member. But there is something that IEEE recognizes is a senior member. Senior member are those people who have certain period of experience after their first degree, and if they qualify for that, they can elevate themselves to senior member level by some procedure. So we basically organize those senior member drives as well. And for this detail, you can later contact me. If you are IEEE member and not yet senior member and you would like to elevate to senior member level, you can contact me personally later on. Okay, so if you are a student member and the graduate student member, the fee is just $27 for 1 year. But now, if you join, you will pay only half of it, and you will get the full benefits until the end of this year. So, which is like 13 US dollars. And if you are a member, you are a professional graduate, so you would like to join as a member. You can also join with a half fee. The full fee is 85 US dollars, but as a half fee, you can just pay 43 US dollars, and then you can become IEEE member to receive the benefits till the end of this year. Okay, as I earlier mentioned that we are in between linking Power and Energy Society. If you become IEEE member, first thing, you get all the IEEE benefits. But to receive the benefits of Power and Energy Society, you have to become PES member as well. So in order to get PES membership, you have to pay additional charges, which are not much. I have to double check how much is the price for the half year, but probably it's not more than 15 US dollar. Okay, and if you are a student and you would like to join IEEE or never join Power and Energy Society in the past, you can join PES for free for first year. So more information for this, you can also contact me. These are the contact details. You can reach to IEEE Power Energy Society Malaysia, our email address and the web address and Facebook. You can find more information about us over there. My email address I will share in the chat box after this presentation. Then you can directly contact me. And here is our current ExCom of 2020, including our chair, past chair, and council, and the current executive committee. With this, thank you very much. And if you have any questions, I will prefer that you write in the chat box after this, because we have a very honorable talk after this. So, or you can just directly reach me by email. Thank you very much. Over to you, Ayar Noor.
Thank you so much, Dr. Haroon, for an insightful sharing about IEEE, Power and Energy Society, and the rest. Okay, ladies and gentlemen, before we proceed with our main webinar speaker, let's together turn on your webcam or laptop camera for us to capture a moment to capture all our participation in today's webinar session. Let's take some time. Takes about 1 minute or so to activate your webcam or a group photo session. Okay. All right. Let's give another 10 seconds for people to activate their webcam. Okay. All right. Okay. Give a smile to the webcam, and we're gonna capture the picture. 1, 2, 3. Okay, let's take another picture. 1, 2, 3. Okay, thank you so much. All right, now we're going to proceed with our main presentation this evening. Let me give some brief introductions about our speaker. Our speaker this evening will be Mr. Eric Koenig. He's the Director of Oil and Gas Strategy and Marketing Segment for Schneider Electric, based in France. He holds Master of Business Administration and Masters of Science degrees in Automation and Business Administration from the National Polytechnic Institute of Lorraine, University in Nantes, France. He possesses a vast experience in the industry with broad industrial automation and energy efficiency system experience. He has also been involved in Schneider Electric business acquisition activities over the last 15 years. So today, we are glad to have Mr. Eric to share with us on the presentations with the topic of sustainability in oil and gas and petrochemical industry. Without further ado, we invite Mr. Eric. Over to you, Mr. Eric. Mr. Eric? Mr. Eric? Mr. Eric, we can't hear you. Mr. Eric, we can't hear you. Perhaps you can unmute your microphone. You can start presenting because you are not presenter.
Can you hear me?
Yes, sir. Yes, sir.
Can you hear me?
Yes, we can hear you. Yes, we can hear you now.
Okay, very good. Okay, very good. All right, that's great. I will try to share the content on my screen. I hope it will work. Otherwise, I will ask you to share. Can you guys see my screen?
Yes, we can see your screen. We can see your screen, and you are
Thank you very
audible.
much for the. Okay, very good. So thank you very much for that presentation. Good afternoon to you. It's still the morning for me, but it's my pleasure to join you at the request of my colleagues in Asia Pac and Malaysia. So as said, my name is Eric Koenig. I'm in charge of strategy and marketing for the oil and gas and petrochemical segment in Schneider Electric. Let me check if you see the second screen. Is it still okay?
Yes, it's still okay.
All right. So what we see and what we understand from our customers is that we have four major trends in our industry. The first trend, and this trend is especially important in these times of challenging oil prices, is to improve the return on investment of our oil and gas and petrochemicals projects. The return on investment means optimizing the capex, the time to first oil or to first gasoline if you are building a refinery, the OPEX costs, the uptime, and the yield. So improving the return on investment is a major issue. A second major issue in our industry is the digital transformation. Another one is the evolution of the workforce, with a big shift where many of the experts are of a certain age and will retire sooner or later. Another major issue is sustainability and energy transition. Probably we have seen that in Europe, maybe a bit earlier than in other regions. And probably Asia and Southeast Asia is the next region to address these topics. And probably the US will be among the last who really take on this topic in the oil and gas industry. So they are not always leading all the subjects, and we see them maybe a little bit later than the other regions like Europe and Southeast Asia. And of course, these four mega trends are somewhat interconnected. You cannot improve the return on investment if you do not have any financial support, if you do not have the social license to operate. The digital transformation is a key enabler to sustainability and energy transition. If you want to hire the younger generation who are more environment conscious, you need to explain them that your company is working on sustainability, is addressing the energy transition, and so on. So really four interconnected subjects. In terms of sustainability, you probably are aware of the 17 United Nations Sustainability Development Goals. And usually in the oil and gas industry, some of these SDGs, some of these United Nations Sustainability Development Goals are more important than others or represent bigger challenges. Here I take an extract of the Shell Sustainability Report, so it's something that's easy to find, and Shell highlights especially the Sustainability Development Goals number 7, 8, and 13. Of course, they also address all the other SDGs, but they claim their main challenges or their main response are on affordable and clean energy, making sure that the oil, that the natural gas that they produce are produced as clean. They want to make sure they are able to address the climate action. And of course, they want to make sure that they provide decent work and economic growth in the various countries where they operate. So I don't claim that the oil and the gas industry should only target these three SDGs, but what I say is that usually climate action and clean energy aspects are the most important or the biggest challenges on these subjects. So most of the rest of my presentation will address the greenhouse gas emissions, or if you prefer, the carbon emissions, because that's a major challenge for our industries. So we, as Schneider, we believe that we can support the oil and gas industry in this subject, because ourselves, we are a recognized sustainability champion. So I don't want to spend too much time advertising Schneider Electric achievements and Schneider Electric position in sustainability, but I suggest, if you have some time, to explore under this link, to explore the Schneider Electric Sustainability Extranet as an example of a company with a very high rankings and recognition on the subject. I will continue more with what we do and how we can support oil and gas companies in achieving their greenhouse gas emission reductions targets. So Greenhouse gas emissions usually are measured on scope 1, scope 2, scope 3. Scope 1 is your direct emissions when you operate, when you use energy and you emit carbon, CO2, or even directly methane in your oil and gas production, refinery, liquefaction, and other operations. Then the scope 2 are the emissions from the purchased electricity, heat, and steam. If you purchase electricity from the local electric utility, of course, you should also incorporate the carbon impact of the energy of the electricity production. If your local utility produces electricity from coal, that means it has a significant carbon impact. If your local electric utility produces electricity from hydropower or wind or solar, the carbon impact is about 0 from this electricity you purchase. Then you need also to integrate the scope 3 at suppliers. If you use, if you buy pipelines, steel structure, switchgear, automation equipment, if you hire consultants or engineers from various suppliers, you need to integrate the scope 3 emissions from all these purchases. And then in the oil and gas industry, of course, you will have also to integrate the scope 3 at customers. If you sell gasoline or diesel to your end customers, usually these end customers will burn this gasoline or this diesel into their engines, into their motors. So you need to integrate these, and of course, this will be a big impact on your total greenhouse gas emission on your scope 3 at customers. So usually, most of the oil and gas companies have now defined very ambitious targets on greenhouse gas emissions, usually in scope 1 and 2, and very often on scope 3 at suppliers and also at customers. So how to reduce these greenhouse gas emissions? So what I propose or what I present is our proposal, our approach as Schneider to support customers and to support oil and gas companies. But of course, whether you do it with us or without us, you will in practice have to follow a similar approach. So the first element is to identify what you want to do. You need to define what will represent a success for you. What are your targets? You will define. You will need to define what is a success and what are the targets. Then you will have to deploy your program and sustain the results. Whether you do it with Schneider or with someone else, I don't care, but you will in practice need to define your targets, define your program, and make sure that you can sustain these results. You will have to apply various solutions. You will have to apply various software, application, hardware, systems to ensure quantified results. And you probably will have to articulate energy efficiency, electrification, and decarbonization measures. So for your scope 1 and 2, you may want to apply an optimized design. You may want to optimize, you may need solutions to optimize power and process control. You may need to deploy leak detection, and you may need to deploy instrumentation. You may need to deploy heat exchange, flue gas recovery measures. You may even want to start with building and retail controls. You may want to electrify some of your processes. You may want to make sure that electricity that you buy comes from renewables, and you may need to use microgrids. You may want to have sourcing with power purchase agreements, energy as a service agreements. If you consider the scope 3 at your suppliers, you may want to assess your supplier's CO2 impact and we can provide the CO2 impact of all the products and systems that we supply to you. And you may inspire from this methodology for your other suppliers. Then you may want to develop your renewable power generation and sell electricity coming from renewables. You may want to develop EV charging infrastructure. You may want to develop into biofuels, into plastic recyclings, into hydrogen, into carbon capture and storage. And again, we can help you on that. And of course, you will need to measure this and to have some kind of CO2 reporting dashboard, and we can help you on this again. So I sometimes advertise what we do, but whether you do it with us or not, these are more or less the steps that you will need to take. So I mentioned three major approaches: energy efficiency, electrification, and decarbonization. So these are three complementary approaches, mainly on scope 1 and 2. She's mainly on scope 1 and 2. So energy efficiency is making sure that your systems, that your operations use energy the most efficiently possible, that you have process optimization in the design over the life cycle, that you optimize your process, your operations, and so on. Then electrification also contributes to carbon optimization, because usually it's better to replace mechanical drives with electric motors and variable speed drives in a number of operations, in a number of processes. If you have electric fracking, it's easier to control than fracking with mechanical drives. If you have your gas compressors, water injection pumps that are managed with electric motors and with variable speed drives, it's easier to control and to optimize than with mechanical drives. And same thing, sooner or later, you will need to check if electric heating of larger furnaces is relevant, because these things are usually easier to control than with gas burners and mechanical drives. And then decarbonization, once you have electrified your processes, you want to make sure that this electricity comes from renewables, which you usually have zero carbon impact. So three complementary approaches. One is not enough. You really need to deploy the three of them. Then you may have different needs as an individual customer. You may want to manage your greenhouse gas emissions in your current operations, in your current refinery, in your current oil or gas production. Maybe you are working on a future plant. Maybe you are designing a new offshore platform. Maybe you are designing a new petrochemical plant, and you want to optimize the greenhouse gas emissions in this future plant. Maybe you want to address carbon emissions in your current office buildings, in your current data centers, in your current petrol stations. So maybe you want to address carbon emissions in your current office buildings, in your current data centers. You probably have hundreds of or thousands of petrol stations. And each of these petrol stations is a small retail shop, and each of them uses energy. And same thing, your office buildings use a lot of energy, and it's an easy target for optimizing carbon emissions. And maybe you want to develop clean energy and not only sell molecules of methane, of molecules of octane, etc., like you do today, but you want, like Shell, to go from molecules to electrons and start selling renewable energies. So depending on what is your target, you may use different solutions. And here I will continue with some of the solutions where we, Schneider, can support you. But of course, you may source these solutions from other suppliers. Just take them as examples, and there may be some other solutions to support you in these different approaches. So don't take them as an exhaustive and unique list. And we are probably not the only suppliers for each of these, but you are welcome to come to us for these solutions. So I will present probably 13 solutions. Maybe I will skip some of them. Mr. Irnoor, please feel free to stop me when I've passed my time. We don't need to go through all of them. It's just a matter of presenting some of these solutions. So if I continue, one solution, and often it's easy to forget, one solution that you should not forget is that safety. You should not forget that safety is part of sustainability. Safety avoids a number of safety solutions, avoid major leaks, major accidents, they avoid unwanted flaring operations, etc. So you all have in mind some of the catastrophes in the recent past. The BP Macondo oil spill, it was not in 2020, I think it's 2010, my apologies. The BP Macondo in the Gulf of Mexico killed 11 workers, injured 17 workers, and that was a start of one of the worst environmental disasters in US history. This catastrophe contaminated 1,100 miles of coastline, so a major catastrophe. It cost BP billions of dollars in terms of money, but it was a major sustainability challenge for the region. So don't forget that safety is sustainability, avoiding accidents, leaks, and flares. It starts very often with a triple redundant safety system. Triconex is one of them. So the emergency shutdown makes sure that your plant stops in a safe mode in case of a major accident. But you, of course, have other process safety solutions like operator training systems, safety advisor, control system modernization, cybersecurity. All of these contribute to the safety and eventually to the sustainability of your plant. Also, don't forget the electrical safety solutions with all the switchgear, asset advisors, augmented operator advisors, etc. So one message, safety is a major part of sustainability, helping you avoid accidents, leaks, and flares. Then another important step for ensuring sustainability are microgrids. So microgrids is what? Microgrid is a system where you combine renewable power generation, maybe other power generation means, plus battery storage, and control and management of demand and supply. So both demand and supply need to be managed. You may want to have some load shedding optimization. You may want to switch off less priority applications, but you have to balance all of that very often with some artificial intelligence solutions that will select the cheapest and greenest available energy at a given time. And of course, that needs optimized system design. Of course, that needs optimized system design. And in some cases, you may even want to call on financing and use your microgrid in an energy as a service approach, where somebody else, a third party, a bank, will provide the upfront investment, and you pay for your energy as you go, as you use it. So that is another element that you want to consider in your sustainability approach. Probably a third one, especially in your areas where you have regular winds, is to deploy wind farms. So a wind farm, of course, starts with a wind turbine, but the wind turbine is not the only element in a wind farm. You have additional controls and switch gears that need to be integrated with this wind turbine. And then the wind turbine needs to be connected to each other. And then the wind turbine needs to be connected to each other and needs to be connected to the grid. And you need to supervise all of these because, of course, the wind is sometimes intermittent. It's not always regular. You need to adjust the production to the needs or vice versa. So wind farm may be an option for you. Or, of course, a solar farm may be another option. I will skip that. Then you, again, a totally different approach. You may want to report on sustainability, and we have tools like Resource Advisor that can help you and can help you reporting on environmental impact. And you can track your carbon impact, your water footprint, your waste footprint across your operation on one site or on multiple sites. So that's another example of a tool that can help you reporting on sustainability. Then another tool that you may want to explore is what we call energy sustainability services. A company like Schneider, but you probably can find other suppliers, can help you purchase energy from various utilities, from various suppliers. They can help you purchase electricity and other energy and optimize this sourcing by buying smarter, by defining exactly your need, and by also integrating the carbon impact of these purchases. So don't hesitate to go for professionals, for professional service operators who help you buy in a smarter way this energy and reduce your energy costs and your purchase costs on energy. You may want to explore this extranet of Schneider Energy Sustainability Services. But of course, this is advertising our company. But you may want to follow such a route of hiring a professional support to buy energy from third parties. Then we have gone, as an example again, we have gone into a partnership, and we have gone into a partnership with a company called Carlyle, the Carlyle Group, which is a major company with 220 billion portfolio of investment. This company typically will invest into a power generation plant if you need power generation. So they will invest in the power generation plant for you, and then they will supply the electricity to you for, of course, for a yearly fee or a monthly fee or a fee per megawatt hour. But they will take the upfront investment of the infrastructure and sell you the service. And these joint ventures that we have built with them will optimize with microgrid and control solutions, will optimize the initial investment and will help you optimize your consumption to make sure that the infrastructure that is built is right-sized and not oversized. Then another solution that we suggest is to have a closer look at the systems that you have in your plant, in your refinery, in your petrochemical plant. You probably have a process automation system and you probably have a power control systems. And most likely, historically, these different systems were designed, managed, and operated in totally independent ways. And what we suggest is to have a closer look at the interaction of these two systems. Very often, by better connecting these systems from the design stage, in the operation stage, in the various optimization stages, by enabling functionalities like load shedding, generator overload management functions, you can really optimize the energy usage and sometimes reach up to 10% process energy usage improvement. So again, you need a more holistic approach to your process automation and power control systems, and see how you can better integrate these to ensure some energy savings in your plants. Another approach that we recommend, especially in the design stage of your plant, is to optimize your complete design. Very often, the EPCs and the people designing your electrical distribution and your complete power system, very often they have a natural tendency to reapply the good old designs of the past. The problem is that these designs were often too redundant, too expensive. You would use a cannon to kill a fly. And if you have a closer look at this and consider strategies to provide really fit-for-purpose solutions, let me take a simple example. You want to consider starting your electric motors one after the others. Okay, it takes you a few more minutes, but if you start them one after the others, you can really optimize the power generation and the power distribution system. Of course, if you really need to start all your electric motors at the same time, okay, but maybe you are ready to start them one after the other, because anyways, you will do that only once a year or once in a lifetime. So it can generate lots of savings in terms of money, in terms of footprint on your offshore platform, and it can generate savings in terms of carbon impact. And we have a number of examples of that, where we have generated savings in terms of CapEx, in terms of CO2 savings, but also savings avoided during the life cycle, thanks to the better control from the control system, thanks to deploying various variable speed drives, thanks to optimizing the electrical distribution system, so we can help you assess the CO2 impact of your complete system. And we have published a white paper and a methodology on that are accessible on our website, Extranet. Then, of course, remember that if you refurbish equipment rather than recycle, if you modernize switchgear rather than just replace them, all of this contributes to limiting your carbon footprint. And at the end of the day, or at the end of their life, make sure that you do not throw away your old transformer into the garbage, but these things can be collected and recycled, and you can make sure that you do not spill the used oil and the used material into the environment. One other example of a solution is what we call predictive emissions management systems. Together with our daughter company, Aveva, we have such systems that can monitor flue gas emissions, and that can be a cost-effective alternative to hardware-based emission monitoring systems. So a number of software can help you optimize the emissions management and the emissions monitoring. And we have installed that at several operating facilities in the Middle East. Then remember that in a number of your processes, you may have exothermic processes, or you have exothermic processes on one side, and endothermic processes on the other side. And of course, you want to recover the excess heat on one side and preheat the fluids, the gases, the stuff, the entrance on the other side. That means you need a number of heat exchangers. And of course, you want to optimize the design, the numbers, the size of these heat exchangers. We have such tools in the Aveva range. They are called Romeo. It's part of the Romeo process optimization tool. We have such tools that can help you optimize the mass and heat balance into your plant, that can help you optimize the pinch methodology, and that can help you save a lot of money, of course, and can help you optimize your carbon and greenhouse gas footprint at the end of the day. We still have other software like advanced process control, production accounting, unified supply chain platform. All of these can contribute to your optimization in terms of money, of course, but also in terms of greenhouse gas emissions. Last but not least, I mentioned your various retail, your various petrol stations, your various office buildings. You may want to check if these office buildings, if these petrol stations are really optimized in terms of air, heat, in terms of HVAC, air conditioning, electrical distribution, etc. Very often you can achieve lots of savings with just simple lighting controls, with just simple HVAC controls. And these are not rocket science solutions. These are solutions that are deployed in millions of buildings across the world. So it's maybe a small hanging fruit, but it's a low hanging fruit that you can address very easily. So I've presented 13 approaches to optimize your greenhouse gas emissions. It's probably not exhaustive, but we have some examples and references of using these. And let me just quickly go through an example of a US gas treatment plant where they had 17 million of annual energy spent on their 3 processing trains. They had self-generation electricity. And with a consulting approach with them, where we spend some time on site, assessing the different energy consumption patterns, identifying the different energy conservation measures, we have deployed a number of measures, and the cost was about $1 million for them, and the savings were $700,000 per year. So in practice, they had a payback of 1.5 years, and it's already a couple of years back. So their payback was huge compared to the initial investment of $1 million. So very often you have very short paybacks in terms of energy savings, energy saving costs, plus of course savings, energy saving costs, of course the carbon impact to the environment. So if I come back to the beginning, one of my main slide, you may have different approaches, different solutions, different measurement tools, but you really need to define what you want to do, to set the targets, to deploy the programs, and be sure that you can measure the results. You can apply various solutions. You can use a toolkits. As Schneider, we can probably provide you some of these, and we are at your disposal for that. But you will need to articulate various solutions depending on what you want to do, depending on whether you want to optimize emissions in your current operations, on whether you want to build a new offshore platform, a new refinery, on whether you want to address the low-hanging fruits in your current buildings, in your current data centers, in your current petrol stations, or whether you want to develop new energies and sell renewable energies to your customer instead of selling them only gasoline or diesel or natural gas. That's it for me. And I will welcome your questions or your comments on the subject. Mr. Irnour, back to you.
Okay, thank you so much, Monsieur Eric Koenig, for very insightful sharing. As we have seen and we have heard, Mr. Eric have provided some insight of how we can begin a journey in realizing the vision of migrating towards a more clean and lean renewable energy. This is also part of our effort to make sure that we still remain and relevant towards creating a sustainable future in the industry for Earth and humanity as a whole. All right, now I would like to invite all participants to pose any questions that you have to Mr. Eric. Based on the chat space here, no question. You can also switch on your mic if typing is taking too long. You can switch on your mic and raise your question to Mr. Eric. Anyone? Okay, maybe while waiting for question to come, I would like to share, to invite you all to provide some feedbacks on today's webinar. Let me share. Perhaps if you can scan this QR code and provide some feedbacks, that will be appreciated. Okay, do we have any question? Mr. Eric. Okay, I guess there's not much further questions. Else, I think again, I would like to invite everyone to provide some feedbacks on today's webinar so that we can better improve our session in the future. All right, just scan this QR code in your mobile device and give your feedback on 2 questions. Okay, I guess there's no further questions. Mr. Eric, I guess that would be all for today's event. We appreciate your presence, waking up early to present to us all the way from across the globe. Thank you so much, sir.
Don't worry, it was 9 a.m. my time. Usually I'm awake much earlier than that. So it was really
Maybe
my
I just
pleasure.
ask one question. Yeah, one question, Eric, about you did not touch about the solar energy as the future to minimize the carbon footprint. So what is your thoughts about that?
I did not touch it, but it is definitely a major source of energy, like wind. I developed a little bit the wind energy. And of course, solar energy is also a great source of energy. And we all know the issue with solar energy. It does not provide any electricity at night. Sometimes you have many clouds during the daytime, but you never have a lot of sun during the night. So you really need to be able to adapt your process for this intermittent character of a sun, of a solar energy, or to make sure that you have large batteries, or that you use less energy during night because you will have less from the solar energy. Hydropower can be also a great tool to ensure carbon neutral energy. Nuclear power is another one because the nuclear may be challenging from some other aspects, but it produces no carbon emissions. But then nuclear energy has other issues, and usually the permitting and the development of such a plant is very complex compared to a solar plant or a wind turbine.
Okay, thank you so much for the question and also for a clear answer from Mr. Eric. Any further questions from all participants? Okay, I guess there's no further questions. With that, I would like to, on behalf of IEEE PES Malaysia Chapter, we would like to thank Mr. Eric for very good presentations that's been shared today. And to the rest of you, thank you so much for attending the webinar. Before you leave, please make sure you please scan this QR code and provide some feedback for our future improvement. Mr. Eric and all audience, thank you so much. And we look forward to see you again in the next webinar. Thank you.
Thank you.
Thank you.
Thank you.